All right, everybody, what's going on? This video, we're going to look at polar coordinates. All right, so to start out, we've got an angle here, and this axis here, this is your polar axis, and what we do is we rotate an angle theta, and we have like a terminal side of an angle here, and we call this the point r theta, where r represents the radius and theta represents the angle of rotation. All right, and then this point right here, we call it the pole or the origin, and we label it. We can label it with the letter O. Okay. Now, here's one where we have r theta, the point up here, r theta, and this point down here is negative r theta. So the radius we have is a negative here, and basically all it is it's just we rotate to this where we have the r theta. We rotate to this, and then we're adding pi to get to this. Okay. All right. So let's come down here, and you know, one of the things that we need to learn how to do is plot points in polar coordinates. So let's look at that. And yes, I know all of my points, all my angles here are in radians, and this is in degrees. This is the only one I could find to bring in, but I mean, you know, this right here, this is pi over 6, pi over 4, pi over 3, this is pi over 2, pi, and then down here at 270, that's 3 pi over 2, and then this is 2 pi when we're back at 360. All right, so let's go ahead and see how we plot these points here. All right, so we've got the point 1, 5 pi over 4. And I think what I want to do here is I want to cross out these numbers here, and let's just label this one right here 1, and this one 2, and this one 3. Okay, so we'll go like that. So we'll go over 1, 2, 3. That'll be, you know, every 2, 3, 1, 2, 3. Every third one will represent 1 unit, and I'll just mark it with a red mark like this. 1, 2, 3, 1, 2, 3, 2. And that way we won't be so bunched up. So each of these marks represents 1 unit. All right, so let's plot the point 1, 5 pi over 4. All right, so 1, 5 pi over 4. So what that means is we go over 1 unit, and then we have to rotate in a counterclockwise direction 5 pi over 4. So we're going to come around, and we're going to rotate 5 pi over 4, which is going to be, let's see, about right here. So this would be the point A. Okay, so you go over 1 and you rotate in a counterclockwise direction. And 5 pi over 4 radians, that's what, 225 degrees. All right, so let's look at this one, 2, 3 pi. So we're going to go out to 2, and then we're going to rotate in a counterclockwise direction 3 pi units. And so we're rotating when we go all the way around, that's 2 pi, and so we have to rotate another pi, and so that would be right here, and this would be the point B. Now let's look at this, negative 2 pi over 3, 2, negative 2 pi over 3. All right, so so how do we do that? Well, we go over 2, but notice this time we're at what? We're at negative 2 pi over 3. So that means we're going to rotate in a clockwise direction, 2 pi over 3 radians. Now, what's 2 pi over 3? If you can do that real quick in your head, that's what, 120 degrees. So we got to rotate negative 120. So that's coming this way, and so that would be right here. And so that's C. Now what about this one? Negative 3 pi over 4. All right. So notice this time R is negative. So in all the first 3 points that we did, R was positive, so we went out however many units to the right. Well, since R is negative, we got to go to the left. So this is negative 3, and then we rotate 3 pi over 4, which is what, 135 degrees. And so that's going to put us over here at right here. And so that would be D. All right, so hopefully that made sense. That shouldn't be too hard for you to do, plotting polar coordinates. You should know how to do that because you took either pre-calculus or trig, and you've seen that before. All right, so let's look at the next thing. We've got the connection between polar and Cartesian coordinates. Okay, so here we have the point written in polar coordinates is r theta, and Cartesian coordinates xy. All right. So let's look at this. We've got our x-axis here. We've got our y-axis here. All right. So if we have a point xy, okay, this is a point xy. So we go over x units, we go up y units, and we'll label this r, and we have a rotation here of theta. Okay, see, r represents our radius and theta the amount of rotation. Well, how would we convert from Cartesian coordinates to polar coordinates, or polar coordinates to Cartesian coordinates? Well, let's look at the relationship between them. So if we look at this, we've got theta here, and we know cosine is adjacent over hypotenuse. So adjacent over hypotenuse, that's where we get cosine theta is x over r. And same thing with sine. We know sine theta is opposite over hypotenuse, or y over r. And that's where this comes from. And then if we solve this one for x, we get x is equal to r cosine theta. We solve this one for y, we get y equals r sine theta. And then this is a right triangle, so Pythagorean theorem just tells us r squared is equal to x squared plus y squared. And then we also know that tangent theta is opposite over adjacent, or y over x. So we'll use this right here to convert from Cartesian to polar, polar to Cartesian coordinates. All right, so let's look at some examples. All right, so what they want us to do here is convert the point 2 pi over 3 from polar to Cartesian coordinates. All right, so remember this is r, this is theta, and we want to convert it to xy coordinates. So we need to know what x is, we need to know what y is. All right, so we know that x is equal to r times cosine theta, and we know y is equal to r times sine theta. All right, so I mean, all we do now is just plug that in, and so we get 2 times cosine of pi over 3 is equal to 2 times, and then the cosine of pi over 3 is 1/2, and so that's equal to 1. And then for this one, we get 2 times sine of pi over 3, which is equal to 2 times, and then the sine of pi over 3, that's square root of 3 over 2, and so we get square root of 3. So our Cartesian coordinate is 1 square root of 3. All right. Now, I know sometimes students get these messed up. Sometimes they'll label this one Y and this one X. Okay. So to avoid that, to make sure you're using the right one, if you're not sure, all you have to do is draw this, and then you should be able to write that down and then solve for X and Y. Okay? At this point, you should be able to do that. So, like I said, if you forget that, just draw this out, and then you can get everything. All right, so here it says represent the point with Cartesian coordinates 1, -1 in terms of polar coordinates. All right, so the way that we want to do this, or what I like to do, is I like to just draw it and plot that point. So if I plot this point, go over 1, down 1. So there's the point 1, -1. Okay. And, it's not drawn to scale, but I really don't care about that, if it's drawn to scale or not. My main thing is I want to know what quadrant I'm in. I want to know what quadrant I'm working with. All right. So we can see the distance from here to here is R, and then I can see this is theta. And I'll talk about this more in just a second about what we're calling theta. All right. So let's get R. So we know R, let's see, let's do it like this. Well, we know that R squared is equal to X squared plus Y squared. So that tells us R is equal to the square root of X squared plus Y squared. And so that's the square root of 1 squared plus -1 squared. And that's going to give us the square root of 2. Remember, R's positive. Okay, we're talking about a radius. All right. So that gives us R. Now we have to figure out what theta is. So we can use the fact that tangent theta is equal to Y over X. So this tells us that tangent theta is equal to -1 over 1. And so we get tangent theta is equal to -1. All right. So from when you learned in trig about the inverse trig functions, this would be what? -40, pi over 4, right? Because remember, when you're doing the inverse tangent, that's what? It's between -pi over 2 and pi over 2. And not including the -pi over 2 and pi over 2 because tangent's undefined there. But this is what I like to do. I like to give theta as a positive angle. Okay? I like to give this angle right here. I mean, the -pi over 4 would be right here. Okay, if we did that. And that would get us to the point. And I'm going to talk about those two different situations in just a second. All right. So let's look at this. So we have tangent theta equals -1. Well, in order to get theta here, I need the reference angle, right? I need my reference angle here. You remember that? Reference angles? So I've got tangent theta prime. Remember, your reference angle is an angle in the first quadrant, and your reference angle is always equal to a positive. Okay, whenever you do the sine, cosine, or tangent of a reference angle, it's always a positive number. And so this would give me theta prime is equal to pi over 4. Okay, so that's my reference angle. That's pi over 4. And so this would give me theta is equal to what? Well, that would be 2 pi minus pi over 4, right? We go all the way around to 2 pi, and then we subtract off the pi over 4. And that would give us 7 pi over 4. And so our polar coordinate would be square root of 2, 7 pi over 4. Okay? And then also an acceptable solution is square root of 2, negative pi over 4. This is also a solution. All right? So we can actually do several different solutions for the polar coordinates. All right, what would be another solution? Do you know what another solution would be? Well, we could do what? Negative square root of 2. Okay, so that means we're coming out this way, and we got to get to this point. Okay, so we're going pi over 2, and then another pi over 4. So what's pi over 2? Pi over 2 plus pi over 4, that's going to give us what? 3 pi over 4? And so 3 pi over 4. There's another solution. Okay, keep in mind, see, when we plot this point, it's going to be right here. When we plot this point, it's going to be this one. When we plot this point, it's going to be this one. And see, we could even go negative square root of 2 over here, and we could rotate this way. So we would go pi plus pi over 4. That would be 5 pi over 4, but we're going in a negative direction, negative 5 pi over 4. So there's another point. All right? But like I said, the solutions I like to do, I like it when r is positive, and then I rotate that in a counterclockwise direction. This is the one that I tend to do. Okay? All right. So now we know how to convert the points and everything. So let's look at some graphs. Not going to get into a whole lot of detail about the graphs and stuff. We'll do some graphs, and then we will get into some calculus, finding tangent lines and that kind of stuff. Horizontal and vertical tangent lines using calculus. All right, so what they want us to do here is they want us to sketch the graph, okay, of r equals 2. All right, so let's look at that. R equals 2. All right, so to graph this, not really a whole lot you have to do. So we notice that r is 2, the radius is 2, no matter what the angle is. And so all this is this is just a circle with radius 2. That's all it is. This is r equals 2. Okay, yes, it's that simple for that one. Now what about this one? Sketch the polar curve theta equals 1. Okay, well, let's do that. All right, so keep in mind that no matter what r is, whether r is 1, 2, 3, -1, -2, -3, theta is always 1 radian. And so if I do this 1 radian, it's just going to be this. This is my theta equals 1 radian. And it's just a straight line. Okay, and then, so, this would be the point r is 1, theta is 1. Okay, r is 2, theta is 1. And so on. And that's all it is a straight line. All right, so now let's look at this. Symmetry. If a polar equation is unchanged when theta is replaced by negative theta. Now, I'm gonna go through and show you how to determine the symmetry and everything. I think it's good to be able to do this real quick, and it'll give you a good way to kind of check and see if you drew your graph right too. So if a polar equation is unchanged when theta is replaced by negative theta, the curve is symmetric about the polar axis. Remember, the polar axis, that's like our positive x-axis. And if the equation is unchanged when r is replaced by negative r, or when theta is replaced by theta plus pi, the curve is symmetric about the pole. And then if the equation is unchanged when theta is replaced by pi minus theta, then the curve, or well, I probably shouldn't have put that in there, huh? It's just the curve is symmetric about the vertical line, y equals pi over 2. All right. So here's your examples. Here's it symmetric about the polar axis. Here it's symmetric about pi over 2. And here it's symmetric about the pole. Okay, see, like if we take this, we can rotate it 180 degrees there. All right, and I'll go through it and show you how to determine that on some of the problems. All right, so let's look at an example. It says, sketch the curve with polar equation r equals 2 cosine theta. Find a Cartesian equation for this curve. All right, so let's determine the symmetry. Let's look at the symmetry. All right, so I'm gonna do this one right here. I'm not gonna do these two because they're not gonna apply. I will do these two in a later example, but let's just do this one where we replace theta with negative theta, and I'll show you. So let's just, you remember when you did this, when you were determining how a line symmetric, if a function was odd or even, okay? So we've got f of negative theta. All right, so I'm going to call this f equals, okay? I mean, I guess we could use r, but I'm just going to use f. So I'm replacing theta with negative theta. That's equal to 2 times cosine negative theta. All right, and so remember your negative angle identities. So we get cosine of negative theta is equal to what? Just cosine theta. So that's equal to cosine theta. And so you can see we ended up with what we started, our original function, f of theta, or r of theta, if you want to look at it like that. Okay, what I'm doing here is I'm replacing that r with an f there. Okay, that's all I'm doing. I'm just saying this is f equals. And so you can see when I did f of negative theta, I ended up with f of theta. All right. All right. So we know now that it's symmetric about the polar axis. All right, so let's draw this. Let's sketch this thing. So to sketch this thing, let's make a table. All right, so I'm going to have theta. And I'll tell you, I'm going to do this in a little bit different color. So we got theta, and then we've got r, which we know r is 2 cosine theta. All right. And what I'm going to do is I'm just going to pick some values for theta. And so what values am I going to pick? Am I going to pick something like 55 degrees or 23 degrees? No, I'm going to pick some values that I know. Okay, values that I know. So let's just start out with 0. And how about pi over 6, pi over 4, pi over 3, maybe pi over 2. Let's do, how about 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. All right, so I used a bunch, okay? I used a bunch of points here. Notice I stopped at pi. So why in this case did I stop at pi? Well, if you remember the cosine function, okay, 0, 2 pi, pi. So you can see once I get here to pi, it just repeats, okay? It's going to be the same values, okay? So I'm just going to go to pi. And so if I evaluate these, well, the cosine of 0 is 1, right? When I plug 0 in for theta, cosine of 0 is 1 times 2 is 2. The cosine of pi over 6 is what? Square root of 3 over 2. Square root of 3 over 2 times 2 is just square root of 3. The cosine of pi over 4 is square root of 2 over 2 times 2 is square root of 2. Square root of, not square root, but the cosine of pi over 3 is 1/2. 1/2 times 2 is 1. The cosine of pi over 2 is 0. 0 times 2 is 0. All right, now let's look at evaluating these. Okay, I'm going to show you how to do this one, and then the same thing applies for the other ones. All right, so I want to do 2 pi over 3, which is say about right there. So there's 2 pi over 3. So remember, to do this, you've got your reference angle. So in this case, my reference angle is pi minus 2 pi over 3, which is pi over 3. So that's pi over 3. Okay. Now remember, the cosine of 2 pi over 3, that's equal to what? What's the cosine of pi over 3? That's 1/2, right? But I'm in the second quadrant, and cosine is negative, so that's negative 1/2. So negative 1/2 times 2 is negative 1. See that? And then the same thing here. I'm going to do the reference angle just like I always do, and just like I did in that one. So this would be negative square root of 2. This would be negative square root of 3. And then the cosine of pi is what? Negative 1. Negative 1 times 2 is negative 2. So you can see I've got all my values. And so now let's plot the graph, or draw the graph. All right. So let's just say this is, let's say we've got 1, 2, 1, 2, and we'll see how good we can draw this. Let's see, right there, maybe about right there. All right, so my marks are not evenly spaced, so my graph may look a little funny, I don't know. All right, so when the radius is 2, my angle is 0 radians, so that's this point right here. And then when my radius is square root of 3, well, that's not quite out here to 1, but it's about right in here. So my angle is pi over 6, which that's like, what, 30 degrees? So that's going to be probably about like right in here. And that'll be about maybe like right there. And then I've got square root of 2, which is a little closer in, square root of 2, and that would be at pi over 4. So that's going to be about right, somewhere like right in there. And then I've got 1 pi over 3, which that's like about 60 degrees. That's going to be about right. I don't know. Let's see. Let me erase that. That's going to be maybe about like right in here, something like that. Okay. Like I said, it's hard to do, you know, when you don't have this stuff. I don't have a polar coordinate system here, but maybe somewhere like right in there. You're just plotting the points, and then at pi over, and then at 0, we're at pi over 2. That's just going to be right here. And then I plot my other points. You know, I would have a point down here. So yeah, I'm going to have these lines coming like this down here for my negative values, like this. But look, if you draw this, see, like this, well, we know that this thing from this, we know it's symmetrical about the polar axis. So this is just going to come down here like this. And it's basically a circle. That actually looks a little better than I thought it would. But yeah, there's your graph. Okay. And I mean, you can go and plot these points. You know, you would come out -1 and then rotate 2 pi over 3. Okay, like that. So that's the graph. Like I said, I'm not going to get real deep into this, but that's, you know, there it is. There's your graph. All right. Now, what was the other thing it wanted us to do? It says find a Cartesian equation for this curve. Okay, that ought to be fun. Let's try this out and see what we get. All right. So to do this, to convert to a Cartesian equation, we're going to use the fact that this is part B, that x is equal to r cosine theta. Okay? Because remember, we're converting this. I'm gonna write the problem down. This is our problem. Y, let me write it in green. We've got y equals 2 cosine theta. This is what we're converting, okay, to Cartesian. All right, so we've got x equals r cosine theta. So that tells me that cosine theta is equal to x over r, right? If I solve for cosine theta. So what does that give me? What does that give me? That tells me, and I'm sorry, this right here is not a y, that's r. So what does that tell me? That tells me that r is equal to what? 2x over r, right? See, well, let's do it like this. That tells me 2 times x over r. Because, see, cosine theta is x over r. So that's 2, I don't know why I keep writing y. 2x over r. So there's r. R is equal to 2x over r. All right. So this tells us that 2x is equal to r squared, right? So let's write this over here. 2x is equal to r squared, which we know r squared is equal to what? X squared plus y squared. So now we have x squared plus y squared equals 2x. See, 2x equals x squared plus y squared. Or we can write that as what? X squared minus 2x plus y squared equals 0. Just get everything on one side. And now let's complete the square on this part. So that's going to tell me x squared minus 2x. Okay, I'm going to leave a little space here, remember that. Plus y squared equals 0. So if I halve the 2, that's 1 squared. That's 1. So I add 1 to this side. And so that's x minus 1 squared plus y squared equals 1. And so look what I have. I have the equation of a circle where the center is at 1, 0, and my radius is 1. And that's that graph right there. So you can see, I know it may be hard to tell, but there's the center, 1, 0, and I have a radius of 1 all the way around. Okay? All right, so that's that problem. Let's look at the next one. Let's look at this. Sketch the curve r equals 1 plus sine theta. All right, so as promised, we're gonna look at the symmetry. Okay, let's look at the symmetry. All right, so let's test this out. So I've got f. Once again, I'm gonna replace the r with the f. So f of negative theta is equal to 1 plus sine negative theta, which is equal to, now remember the negative angle identity here is sine negative theta is negative sine theta. So I didn't end up with what I started with. So that tells us we're not symmetrical about the polar axis. Okay. So now let's look at this one. F of theta plus pi. See, we're doing this one right now. Let's see. This one right here to see if it's symmetric about the pole. Okay. All right, so let's do that one. And so this is equal to what? Well, this is 1 plus the sine of theta plus pi, which is equal to 1 plus. Now, what's the sine of theta plus pi? Remember your sum and difference identities from trig. So that's going to be sine theta cosine pi plus cosine theta sine pi. And so that is going to give us what? 1. See the 1 right here. Now let's see. Cosine pi is -1. So -1 times sine is negative sine theta. And then the sine of pi, well, this whole term here just goes to 0. And so you can see we didn't get what we started with. So it's not symmetrical about the pole. All right, so let's try the next one. That's going to be f of pi minus theta. All right, so that's this one right up here. So it says if the equation is unchanged when theta is replaced by pi minus theta, the curve is symmetric about the vertical line pi over 2. All right, so let's see if we have that. All right, so this is going to be 1 plus the sine of pi minus theta. And so that's going to be 1 plus, and then we're going to expand it out again. That's going to be sine of pi cosine theta minus cosine pi times sine theta. Now, once again, that goes to 0. We're going to be left with 1, this 1 right here, and then cosine pi is -1. So that's negative sine, a negative and a negative is positive, so that's plus sine theta. And look at that. We ended up with what we started with. So we know this is symmetric about theta equals pi over 2. All right. So, it's good to know this. We can see if we're even close to the way we, graphed our polar equation. All right. So to graph this, let's look at it like this. Let's draw. Let's graph it like this. And so there's 0. There's 2 pi. So there's pi. There's 3 pi over 2. And there's pi over 2. There's 1, 2. Whoop. 1, 2. And then down here I've got -1, -2. So remember, sine starts out at 0, and then it goes to 1, 0, -1, 0. So it starts at 0, but remember, all of it is shifted up 1 unit. So from 0, see the +1 here. Let's write down our function, our equation again. R is equal to 1 plus sine theta. This is what I'm graphing over here. All right. So sine starts at 0, then it goes up to 1, and then at pi over 2, it's at 1, so that's going to go up 1 to 2, and then we're going to go to here, and then at 3 pi over 2, we're at -1, but plus the 1, and then here. So we can see, if we graph it, there's that. If we're just graphing 1 plus sine theta. Okay? All right. And keep in mind, this is theta, this is r. All right. Now, let's graph it on our polar coordinate system. Okay? Let's look at this. So we know this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. So let's see what happens here. So we know when theta is, or when r is 1, theta is 0. So let's do 1, 2, 1, 2, 1, 2. Okay, so we're here. That's this point right here. Now, let's look and see. As we go from 0 to pi over 2, okay, as we're moving from 0 to pi over 2, what's happening? Well, this is increasing. R is increasing from 1 to 2. You see that? So as we move around, we're increasing. Let's see if I can draw this. See how good I can draw this. Something, that's not very good. Okay, anyway, it's going to look something like that. Okay, something like that. All right, now, as we move from pi over 2, so we're going to go from pi over 2 to pi. Pi over 2 to pi, what is it doing? It's decreasing. See how r is decreasing from 2 to 1? So it's decreasing to this 1 here. And I may need to move that out a little bit. Okay, so it's coming like this. You see that? And look, this is supposed to be symmetrical. I know I'm not drawing it symmetrical, but you know, you know where I'm coming from when you're trying to draw graphs. So, all right, now let's look at this. I'm going from pi to 3 pi over 2. So from pi to 3 pi over 2, it's decreasing from 1 to 0. R is. So from 1 to 0. So it's going to look something like that. And then look at this, from 3 pi over 2 to 2 pi, 3 pi over 2 to 2 pi, it's increasing from 0 to 1. So it's going to come like this. And we can see, you know, like I said, there's a good way to check to see if we drew it correctly. Is this thing symmetric about pi over 2? Yeah, it is. Okay, so there's the graph. All right. All right, now let's look at this one. This is the last graph we'll do, and then we'll get into some calculus stuff. All right, so this thing is, and I'm not going to go through and do all the symmetry stuff, but you know, I showed you in the last example how to do that. So this thing is symmetrical about the polar axis, it's symmetrical about the pole, and it's symmetrical about theta equals pi over 2. Okay, so I'm not going to go through and work it all, but cosine of negative theta, if we did cosine of 2 times negative theta, that would give us cosine 2 theta. And if I did cosine of 2 times theta plus pi, that would also give us cosine 2 theta. Like I said, I'm not going to show you all the work. And then cosine of 2 times pi minus theta, that would also give us cosine of 2 theta. And you can go and fill that in. On these two, you would just distribute the 2, and then you would have to use your sum and difference identities for cosine, just like I did up there with sine. It's the same thing. Okay? All right. So now let's look at the graph here. All right, so I wanna break this one down even more. We can look at the graph from 0 to 2 pi, but let's look at it from 0 to pi and pi to pi over 2, and see what we got here. So let's call this pi. So that means this would be pi over 2. This would be 3 pi over 4, and this would be pi over 4. And then if I come out here to 2 pi, well, let's split this in half. So that would be, 3 pi over 2. This would be 7 pi over 4. And this would be 5 pi over 4. And we got 1, we've got -1. And so we'll be here, 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 and then here, and then back down to here. Is that right? Yeah. And then here, here, and then here. All right, so our graph is going to look something like this. Now what would be a reason why I would go from 0 to pi, and then pi to pi over, and then from pi to 2 pi, and also keep in mind that's theta, that's r. So why would I do that? Well, look at this. If we're graphing, if we're looking at our equation, we got r equals 2, we got r equals cosine 2 theta. Well, what's the period? The period, remember, is 2 pi over b, which is 2 pi over 2, which is equal to pi. So I'm graphing it. I'm graphing 2 periods of it. Okay. All right, let me keep this one. R equals cosine 2 theta. Now let's look at this graph. What in the world is this graph going to look like? All right, so we've got 1, 1, 1, 1. All right, so when r is 1, okay, when r is 1, our angle is 0. So we're right here. Okay. Now, when r is 0, see, r is 0, this is our, like our y-axis r, we're pi over 4. So that would be back here, right? So that graph, and what is it doing? It's, as we move from 0 to pi over 4, it's decreasing from 1 to 0. Okay? See, here's your pi over 4 right here. There's pi over 4. There's another 45 right there. So it's decreasing from 1 to 0. All right? And then as we move from pi over 4 to pi over 2, pi over 4 to pi over 2, it's what? It's still decreasing to -1. So that's going to come right here. You see that? And then as we go from pi over 2 to 3 pi over 4, okay, what is that doing? That's going back up to 0, like this. You see that? And all it's going to do is just going to continue on in that pattern. And see, as we move from 3 pi over 4 to pi, so 3 pi over 4 to pi, that's going, it's increasing to 1, so it's increasing from 0 to 1. And this is all you're doing. Look, it's just going to follow this pattern. And there it is, it's a rose. And yes, it's supposed to all look the same. But look, you know, once you got this right here drawn, you could have just mirrored this over. And then you could have mirrored it over this way. All right. So there's the graph of that. And you know, it's a good way to check. You can see how we get all that, how it's about the symmetry. Okay. All right, so that was a quick thing on just, I guess, kind of maybe refreshing your memory on how to graph those things. All right, now let's look at this. Now let's get into some calculus. So we got tangents to polar curves. So to find a tangent line to a polar curve, r equals f of theta, we regard theta as a parameter and write its parametric equation as x equals r cosine theta, which is f of theta cosine theta, and y is equal to r sine theta, which is f of theta sine theta. See, we're going to say r's f of theta. Then, using the method of finding slopes of parametric curves and the product rule, we have dy dx is equal to dy d theta over dx d theta, which is equal to the derivative of r with respect to theta times sine theta plus r times cosine theta, and that's all over the derivative of r with respect to theta times cosine theta minus r times sine theta. And we locate horizontal tangents by finding the points where dy d theta equals 0, provided dx d theta does not equal 0, and we locate the vertical tangents where dx d theta is equal to 0, provided dy d theta does not equal 0. So let's look at our example. We've got this right here, so let's see what we can do with it. So it says for the cardioid r equals 1 plus sine theta, find the slope of the tangent line when theta equals pi over 3. So we know to find the tangent line, what do we have to do? Well, we've got to find the derivative, and then we evaluate the derivative at this theta here. All right, so I've got dy dx is equal to, and I'm just gonna copy down the formula again. So I've got dr d theta times sine theta plus r cosine theta over dr d theta times cosine theta minus r sine theta. All right, so let's see what we get. So this is going to be what? That's going to be cosine theta times sine theta. Okay, so look at this. Dr d theta, well, what's the derivative of r with respect to theta? Well, the derivative of this, derivative of 1 is 0, derivative of sine is cosine times sine theta. Okay, plus r, so 1 plus sine theta. See, r, what's r? R is 1 plus sine theta. There you go, right there. Times cosine theta. Times cosine theta. And that's over dr d theta. Well, we know that's cosine theta. Times this cosine theta. Minus r. Well, what's r? R is 1 plus sine theta. 1 plus sine theta times sine theta times sine theta. All right. So now all it is a matter of simplifying. Okay, so let's simplify this thing. All right, so let's see. We've got, this is going to be cosine theta sine theta plus cosine theta plus cosine theta sine theta. So all I did here is I just distributed that. Okay. And this is over, well, that's going to be what? Cosine squared theta. Okay. And then I'm going to distribute this. Once again, I'm going to distribute the sine here, but remember it's negative sine. And so that's going to be minus sine theta minus sine squared theta. All right. All right, so what now? Well, this is going to be what? Cosine theta plus 2 cosine theta, sine theta. See, I got a common term here and here. I just added those together. Now, this one, well, what can we do? What can we do here? Well, not much I can do with the cosine squared and sine squared. Okay, it would be nice if it was cosine squared plus sine squared. That would give us 1. We know that. So since this is a sine here, maybe I get this written in terms of sine. So I know cosine squared is 1 minus sine squared. Remember, sine squared plus cosine squared is 1. So I'm just solving for cosine squared. Minus sine theta minus sine squared theta. And so let's combine these two. Not much else I can do with the numerator up here. Well, yeah, I guess we can. Let's do this. Let's factor out a cosine theta. How about that? And that's going to be 1 plus 2 sine theta. And that's going to be 1 minus sine theta minus 2 sine squared theta. All right, so we're moving along. We're getting there. And so this is going to be cosine theta times 1 times 1 plus 2 sine theta over, now let's factor that denominator. That's going to be what? 1 minus 2 sine theta times 1 plus sine theta. Factor it out like that. All right. Now I'm ready to evaluate this thing at what? At pi over 3. So I'm going to plug the pi over 3 in for theta and simplify it and see what I get, because I'm looking for the slope of the tangent line. Now, one thing you might be asking or might be thinking, why in the world are you taking it this far? Okay, why are you going down to this? Why not just stop it right there and plug pi over 3 in and get your answer? It would give you the same thing, right? Well, that's right, it would. But look at the next part here. Find the points on the cardioid where the tangent line is horizontal and vertical. So in order to find out where it's horizontal and vertical, we've got this. See, we've got to figure out where dy, d theta, and dx, d theta, where those are 0. And so we're going to be setting this, which is the numerator, equal to 0, and this, which is the denominator, equal to 0, and have to solve for theta. And in order to do that, I'm going to need to get it down to this point anyway. Okay, so that's a reason there. All right, so now let's look at this. We've got dy dx, and I'm going to evaluate this at theta equals pi over 3. And that's going to be cosine pi over 3 times 1 plus 2 sine pi over 3 over 1 minus 2 sine pi over 3 times 1 plus sine of pi over 3. Okay, so I've got everything plugged in. So this is going to be what? 1/2 cosine of pi over 3 is 1/2 times 1 plus 2 times, and then the sine of pi over 3, that's square root of 3 over 2. You have to know those. Okay, sine, cosine, and tangent of pi over 3, pi over 4, pi over 6. You've got to know those. Okay, if you don't know them, then you need to learn them. All right. And then we have 1 minus 2 times the sine of pi over 3. So that's times square root of 3 over 2. And then 1 plus, and then the sine of pi over 3 is square root of 3 over 2. All right. So let's simplify it a little more. Yeah, I'm sure you could probably punch this into your calculator, but that's no fun, is it? So we've got 1/2 times, and then we've got 1 plus square root of 3. See, the 2's cancel. Over, and then I've got 1 minus square root of 3. The 2's cancel, and then times 1 plus square root of 3 over 2. All right. So what is that going to be? Well, I guess the smart thing for us to do would be to get rid of the fractions. And to do that, I'm going to multiply by 2 over 2. And so that 2 and that 2 is going to cancel. So I'm just left with 1 plus square root of 3, right? And then when I multiply this 2, I'm going to distribute it here. See, that 2 is going to cancel. So I'm left with 1 minus square root of 3. See, that's that one. And I'm distributing the 2 here. That's going to be 2 plus square root of 3. All right. And so now, and look, do not, this 2 here, it's times the 1/2, it's gone. You don't distribute the 2 to that also. And then the same thing here, it's 2 times this. You don't then go 2 times that. Okay, this is like doing 3 times 4 times 5. There's your 3, there's your 4, and there's your 5. When you multiply this, you say what? 3 times 4 is 12, and 12 times 5 is 60. You don't do 3 times 4 is 12, and then 3 times 5 is 15, and then multiply those. Okay, so don't make that mistake. Yes, I've seen it happen, so that's why I mentioned it. All right, so let's full that out. So that's 1 plus square root of 3 over, that's going to be 2 plus square root of 3, 2 plus square root of 3 minus 2 square roots of 3 minus 3. Negative square root of 3 times square root of 3 is 3, or minus 3. And so this is going to give us 1 plus square root of 3 over, let's see what we got here, negative 1 minus square root of 3. Oh, look at that. That worked out real nice, didn't it? Let's factor out a negative 1. Look at there, 1, 1. So we got negative 1. There's your slope. Okay. All right. So now what did it tell us to do? That was only part A. See there, that was part A. This is a long problem. Part B, find the points where the tangent line is horizontal or vertical. All right, let's do that. So remember, horizontal tangent lines by where dy d theta is 0, that would be our numerator, and vertical tangents where dx d theta is 0, that would be our denominator. And so what I'm going to do here is let's see if I can do this. And then let's move this down, because that's really what we need, isn't it? All right, let's just put that right there. All right, so this is this was our dy dx, right? That was our derivative. And remember, the numerator here is what? Dy. Well, I tell you what, let's do it like this. So this is dy dx, which is dy d theta over dx d theta. Okay, so let's find horizontal tangent lines. So for horizontal, we're taking cosine theta times 1 plus 2 sine theta equals 0. Now, this goes back to what? Solving trig equations. Do you remember how to do that? Of course you do. If you don't, I will work this one out and show you how to do it. I'm not going to go through and do all the trig and the dx d theta, but it will be done similar. Okay, so we got it factored. So we say, okay, cosine theta equals 0 or 1 plus 2 sine theta equals 0. All right, so for cosine theta equal 0, this is a theta. I know it doesn't look like one, but it is. That's a theta. So whenever I have cosine or sine equals 0, 1, negative 1, sometimes you may remember what the answer is, sometimes you may not. In case you don't remember, what I would suggest doing is just, that's cosine. There's 2 pi, there's pi, there's 3 pi over 2, and there's pi over 2, and there's 0. Well, where's cosine 0? It's 0 there and there. So here we get theta is equal to pi over 2 and 3 pi over 2. Man, how easy was that? All right, now let's do this one. So we've got to do sine theta is equal to negative 1/2. All I did is I solved for sine theta. Now, reach deep down into your mind and remember when you were solving trig equations. I've got sine theta is equal to negative 1/2, right? Sine theta is negative 1/2. So, my solutions are where? In the third quadrant and the fourth quadrant, right? That's where sine is that's where sine's negative. All right. Remember, you go and find your reference angle, so you can use your reference angle to get your solutions. So I've got sine theta prime is equal to positive 1/2. So theta prime, well, that's what? Pi over 6, right? There's my reference angle. So let's find my third quadrant solution. So there's theta, there's my reference angle, pi over 6. So here we have theta is equal to what? Pi plus pi over 6, which is 7 pi over 6. Okay, so here I'm going to get theta is 7 pi over 6. There's one solution. Now I need my fourth quadrant solution, so I'll draw that up here. I need my fourth quadrant solution. I need theta. There's my reference angle, pi over 6. So here I get theta is 2 pi minus pi over 6. All right, so that is going to give us what? 11 pi over 6. So we got 11 pi over 6. So my possible horizontal tangents are theta equals pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. Okay? That's for horizontal. Now for the vertical, I've got, where is it? This right here equals 0. Okay? So, and I'm going to erase this right here. And I know some of you might be thinking, oh, you went through all that doing reference angles and all that stuff to get those values. Well, I know the unit circle. I could have gotten all that from the unit circle. Yeah, you could have. But what happens if it's not on the unit circle? Instead of this equaling negative 1/2, what if that equaled negative 0.32? What would you do then? You've got to know how to do reference angles, okay? All right, so now setting the denominator equal to 0, we're going to do our vertical. So I've got 1 plus sine theta times 1 minus 2 sine theta equals 0. And so I've got, and so what you're going to do is you're going to set each one of these 1 plus sine theta equal to 0, or, and then you've got 1 minus 2 sine theta equals 0. And you solve them, you know, just like I did these over here. You're going to have sine equals -1. Draw your sine function. Where is it -1? Well, it's -1 at 3 pi over 2. All right. But after you go through all that and you do all that solving, all that work and everything, you end up with theta equals 3 pi over 2, pi over 6, and 5 pi over 6. All right. So hopefully that made sense. All right. But look at this. We have a problem, don't we? You see that? You see the problem we have? 3 pi over 2 is 0 in the numerator and it's 0 in the denominator. So we actually have to look at this a little more. Okay? We got to look at this a little more. So what do? Well, let's take a look. All right. So what I'm going to do here is to determine if, let's just look and see if this is a vertical tangent. Do you remember back when you learned how to do vertical asymptotes? Hey, you remember that? You had to do the limit as x approached whatever number from the left or the right, and you had to show that it equals infinity or negative infinity. Remember that? So I'm going to do the limit as theta approaches 3 pi over 2, and we'll go from the left, of dy dx. And so that's going to be the limit as theta goes to 3 pi over 2 from the left of dy dx. Well, what's dy dx? There's your dy dx. Okay, so we got to do the limit of that thing. So let's see if I can grab this thing again and maybe just pull it down so I don't have to write it again. All right, come on, let's go, come on. All right, there we go. So we'll just drop that thing right there. Okay. So this is, remember, that's your dy dx. Now, looking at this thing, I'm sitting there thinking to myself, how in the world am I going to take the limit of that? Well, we know when we put 3 pi over 2 in, we're going to get zeros, right? Let's see what happens when I take the 3 pi over 2 and I plug it in here. Let's just look at each factor. Okay, when I plug it into here, that's going to give me 0, right? That'll give me 0. When I plug it into this one, the sine of 3 pi over 2, okay, remember, let's look at this. Okay, there's 2 pi. There's 3 pi over 2 right there. There's pi. There's pi over 2. So 3 pi over 2, that's going to be -2. 1 minus 2 is -1. So that actually gives me a number there, doesn't it? And then when I plug the 3 pi over 2 in for theta right here, that's going to actually give me 3 as an answer, right? Because that's going to be -1. So that's -1, -2 is +2, plus 1 is 3. Okay, so this one and this one are giving me numbers, and then when I plug it into here, well, the sine of 3 pi over 2 is -1. 1 minus 1 is 0. Oh, so I've got a 0 here, I've got a 0 here, and these two actually give me a number. All right, so let's look at that. So how about we do this? Let's write the limit as theta goes to 3 pi over 2 from the left of 1 plus 2 sine theta over 1 minus 2 sine theta. Okay, do that. times, and then we've got the limit as theta goes to 3 pi over 2 from the left of cosine theta over 1 plus sine theta. Okay, how about that? Let's see what that's going to do. We can do that, right? We can split them up. Remember your properties from limits. Okay. So this is going to give us, we already went over this. This right here is going to give us what? When we plug the 3 pi over 2 in, that's going to be -1. So -2, 1 minus 2 is -1 over, and then remember this one was what? 3. Okay. And then times, now remember when we do this, we get what? We get 0 over 0. Oh, do we remember what that is? You remember L'Hopital's rule? And so we can write this as the limit as theta goes to 3 pi over 2 from the left of what? Of negative sine theta over cosine theta, right? All right. So we used L'Hopital's rule there. So let's see what's happening here. So what is that limit? Well, let's calculate this limit. So, when we plug it in, that's going to give us sine of 3 pi over 2 is -1. So that's going to be +1 over 0. Okay. But let's look at it even more. Okay. Let's look at it even more. Let's don't say, well, it's just 0. Let's understand this stuff. Maybe you'll learn a little bit more here too. All right. So there's the graph of sine. And then if I look at the graph of cosine, there's 2 pi, 3 pi over 2, pi, and pi over 2. So we're coming in from the left-hand side, right? We're coming in from the left-hand side to 3 pi over 2. So we can pretty much say that you understand that the numerator is pretty much 1. Because as we're getting closer and closer to 3 pi over 2 from the left, this is getting closer and closer to -1, and a -1 and a negative is a +1. So that's pretty much going to be that. Okay? Now, what about for cosine? As we come in to cosine of 3 pi over 2 from the left, okay? We're coming in from the left, right here, okay? What do we have here? Well, that's pretty much going to what? It's getting closer and closer to 0. It's getting smaller and smaller and smaller. Okay, you see that? Smaller and smaller and smaller. And if I have a number that's getting smaller and smaller and smaller in the denominator, and this is kind of staying at 1, well, this thing right here is going to -infinity. Because, we're below the axis here. We're down here with negative values. So it's like plugging in a -0.1, a -0.0001, and so on. So that's like going to -infinity, and then the negative here, this is going to +infinity. So what does that mean? What does that mean? So that means we must have a vertical tangent line. A vertical tangent line at 3 pi over 2. All right. So we don't have a horizontal tangent line at 3 pi over 2. We've got a vertical tangent line at 3 pi over 2. And then, if you want to, you could take these, plug them back into the equation and get your R values. I'm not going to do that. I mean, I'm already almost an hour and 20 minutes, so I'll let you do that. Okay. But yeah, there it is. That's the video. I hope you learned something. I hope you enjoyed it. Hope you didn't fall asleep. So, hope the video helped. Go check out my other videos. Give me a like, share, and subscribe. Thanks for watching. See y'all in the next one. Later.